Hi everyone, so I'm going to do the review sheet for your test. So for the first question, it says the value of the expression r equals 3 sigma to the fifth of negative r squared plus r is. So this is a sigma, and you should remember that sigma, the symbol sigma, means that you need to do a sum. And for this sum, I'm going to evaluate the sigma at 3, 4, and 5. Like in class, the way that I visualize it is that this is a ladder, and I have to go up every single rung to get up to the fifth rung of the ladder. So I'm going to plug in r with the 3 first, then plug in r with the 4, and then plug in r with the 5. So the only thing that you need to be careful of with this specific problem is the fact that the negative is outside of the 3 squared, 4 squared, and 5 squared. It is not inside the parentheses. If we had something like this, that would be a different story. But because the negative is outside the parentheses, this evaluates into negative 9 plus 3, negative 16 plus 4, and negative 25 plus 5. That gets me negative 6, negative 12, and negative 20. When you add all those up, you get negative 38. The next question says, Julian wants to save up to buy a car. He is told that a loan for a car costs $274 a month for 5 years. But Julian does not need a car presently. He decides to invest in a structured savings plan for the next 3 years. Every month, Julian invests $274 at an annual interest rate of 2% compounded monthly. The formula for a future value of annuity in terms of recurring payments are interest rate I, number of payment periods, N is given below. So annuity is how much money you would have after you've been investing for a certain amount of time. It's basically like a savings of your money with interest being built upon that. So you're getting even more money than you intended. So AF is the value of your annuity. The recurring payment is R, your interest rate is I, and number of payment periods, that's how many times you're investing the money, is N. So in this scenario, R is equal to 274. That's how much money he's putting into the bank. He's doing it for 3 years, but every month. So if you see in here, he says he decides to invest in a structured saving plan for the next 3 years. Every month he invests it. So N is really going to be 3 times 12, which is 36. Then for the I, you have to realize that this interest rate of 2%, first off, I'm going to change it to a decimal, needs to be broken up into months. Right now, the interest rate is an annual interest rate, but they're doing it monthly. So we have to divide that by 12 before we do anything with it. So what I'm going to do is plug everything accordingly into the formula. You could, if you want, like evaluate 0.02 over 12 and get that decimal, but I just plug it all in at once. I'm going to put 274 as the R, and then 1 plus 0.02 over 12. N is 36, minus 1 all over 0.02 over 12. Type this into your calculator. You can do it in steps. I just do it all at once and use alpha y equals. And I end up getting that his annuity would become $10,157.21 after 3 years. The last question in this part, it says, what are the benefits of investing in a structured savings plan instead of taking a loan out, and what are the drawbacks? Well, taking a loan, you're owing the bank money, but if you make a savings plan, you don't owe anyone any money. You're just gaining money on your money. So the interest that you're being charged for this problem, you're not being charged that interest. You're gaining money. You're adding interest to the money that you have already saved. With a loan, you're gaining interest, but towards the loan. So meaning that you need to pay more money to the bank. Hope that makes sense with what annuity is and what a loan is. So basically, annuity, you're saving your own money, and a loan, you're borrowing money. So with your annuity, you're going to build money off of your investment, but with a loan, you're going to have less money because you're putting more in to pay off the loan. The next question says, a video of a grumpy cat has gone viral. On the first day, the video was viewed 6,000 times. This is my A1. Each day, the number of visits increased by 40%. Right away, I know this is a geometric process because it's a percent. And because it's increasing, I know my rate is 1 plus 0.4. Think of it as 6,000 is 100% on day 1, but then you're adding 40% to that day 1. So you're adding 40% to the 100. So basically on the second day you have 140%. So that's why we add the 1 to the R. So that's my R value. Now they want the cumulative number of views for the first 2 weeks. I put a hint in for this question. It's not going to be a hint on the Regents or the test, just to direct you in the right direction. But the cumulative, this thing here tells you want a sum. And because it's percents, it's a geometric series. Remember, sum means series. So I'm going to take the reference sheet formula that refers to geometric series and just plug it in. So A1 is 6,000 minus 6,000, 1.4 all over 1 minus 1.4. Now I'm just going to put in the n. This is 2 weeks, but we're talking about days, so my n is actually 14. And if you type that all into your calculator using alpha y equals, you actually end up getting the choice of 2. So they tell you in this problem the third and fifth term of a sequence are 16 and 36. They want you to find all possible values for the fourth term if the sequence can be arithmetic or geometric. So let's do the arithmetic version first. For arithmetic, what you want to do is you want to find D to see how much it's going up by. With arithmetic, if you remember from class, I explained to you that an arithmetic sequence is just a line when you plot it. So that means that I can just subtract these two things. So I can do 36 minus 16 and divide it by how many steps you went up. So 5 minus 3. Essentially, I'm just calculating slope. That tells me D is 10. Since I know D is 10, well, that tells me that if I know A3 is 16, then A4 must be 26. This is one possible value for A4. For geometric, it's a little bit more complicated, but not too bad. What you're supposed to do is, there's a different way to do this. I do it with the formula because I want to find R to figure out what A4 is. So I pretend that A3 is really A1. And I put A1 in as 16. And then because I have 36, well, I'm going to pretend like that's A3. It's going to work because if this is 1 and you went up to 3, okay, that's how the placement of the sequence is. So I'm going to replace AN with 36, and I'm going to put in 3 for the n because I'm pretending that 36 is A3. This gets me R squared. I'm going to divide by 16. When you do that, when you type it into your calculator, you get 2.25 as a decimal equals R squared. And to get R, I'm going to take the square root. And I end up getting plus or minus 1.5 as your R value. Now with geometric, you have to remember that it can alternate signs, and it can just not alternate signs. So in this scenario, we know that A5 is 16. To get A4, I'm going to take 16 and multiply by 1.5. So that would be 24. But A5 is 36. And with a geometric sequence, you could also multiply by a negative, meaning that a negative 24 is also a possible answer for A4. This should make sense because if the rate was positive, that means you would just be positive, so 16, 24, 36. But if the rate was negative, if you multiply by negative, you get a negative, but if you multiply this negative by a negative, you will get a positive. And that's why this works out. So the possible answers are 26, 24, negative 24. A car depreciates at a rate of 15% per year. If a new car is bought at the price of $35,000, which of the following recursive formulas? So this is a very important thing right here. Models the price of the car n years after it was purchased. When you see recursive, you need to have a let statement. So right away, I'm going to see which ones have a let statement. 1 and 2 do not. Here's my let statement. A0 equals 35,000. That's the amount of the car on the first day that you have it, okay? So I know that 2 and 4 are what I'm left with. Now the distractor is this choice here because it has 0.15 in. But you have to remember, when you depreciate, what you're doing is really taking away 15% from 1. You're taking away from the 100% that your car was worth. So that tells me that I'm really a 0.85 rate. And there's my answer. Write the explicit formula for the fifth and find the 50th term of this sequence. Now, first off, you have to figure out what kind of sequence it is. So looking at the numbers, you know it's going down, but by what? What I did was I subtracted 2 minus 5. I got -7, but you always have to check. So -9 minus -2, that's still -7. You should always check with the second one to see if it's consistent. So this is an arithmetic sequence with the d value equaling -7. To get my explicit formula, all I have to do is go to my reference sheet and write down the formula for arithmetic sequence. Remember, this formula finds any term you desire. So all I have to do is plug in A1, that's 5, and then D is -7. I'm going to put this in to write it in simplest form, and I have -7n plus 7, and adding like terms, 5 and 7 get you 12 minus 7n. Okay, now they say use that formula to find the 50th term. So all I have to do is take the formula that I used or made is n plug in 50 for n. So everywhere I see an n, I will put in a 50. So it'll be 12 minus 7 times 50. And that gets me an answer of -338 as my 50th term. The next question says, use summation notation to write the series -1, 2, 5, 8, 11 for 10 terms. Right away, I want to make sure that it's going from 1 to 10. And then it says evaluate the sum. So from 1 to 10, that's every single choice. You can see the bottom of the sigma for every single sigma is 1, and the top for everyone is 10. And obviously the value for the sigma is 125, because every single choice is 125. Really what's different is the inside. Okay? So let's figure out what kind of series this is. This is a series because there's addition, by the way. Series is a sum of a sequence. So let's figure out what kind of sequence is being summed. If you look at it, it's going up, and it's going up by 3. So your D value is 3. This is arithmetic. So because it's arithmetic, get rid of choice B, because this exponent here means geometric. That's the formula A1 r to the n minus 1. We don't want that because this is arithmetic. It's clearly adding 3. Okay, choice D makes no sense because it made the 3 negative. So really you're left with A and D, and A and C. So if you're really lost, what you could do is plug in 1 and see which one gives you -1. Like if I put in 1 for this one, be 3 minus 1, that's 2. That's not the first term. But if I plug in 1 for this one, that's 3 minus 4, and that's -1, which is the first term. So it has to be choice C. But the actual way to do this problem is to use the explicit formula. What I just did now was just use the choices. But to see how they get this 3n minus 4 for the answer, just plug in A1 is -1, D is 3. Putting this in, I get -1 plus 3n minus 3. And here's your like terms, so 3n minus 4. And that's how they got that. And that's your answer, C. State the recursive formula and the explicit formula for the sequence this. So first off, figure out what kind of sequence it is. If you notice, the signs are alternating from positive, negative, positive, negative. When the signs alternate, most likely it's a geometric sequence, because if you multiply by negative and you're multiplying a negative, you get a positive. But if you multiply positive by a negative, you're going to get a negative. So this is probably geometric, and I'm going to check by doing -2 divided by 1, which is the second and the first term being divided. And then I'll do the third and the second, and look, it's the same thing, and just to be safe, -8 divided by 4 is -2. So clearly it's geometric, with an r value equaling -2. So if I want my explicit, this one's the easiest one to do because it's on your reference sheet. I'm going to write this off the reference sheet, and then I'm going to plug in a1, which is 1, and then r, which is -2, to the n minus 1. Honestly, I don't need the 1 there. I'm just going to really simplify this by writing it as -2 to the n minus 1. So that's the explicit formula. For the recursive formula, remember you need two parts. The first part is the let statement of what a1 is. You don't have to state a1, you could do a2, a3, it doesn't really matter. I always use a1, so we got to state that. And then you also have to fill in the formula an equals, I say, ran minus 1. Okay, so I'm going to plug in a1, and in this case, a1 is 1. Okay, so a1 is 1. And then I'm going to plug in r as -2. So I'm going to erase this and put r in as -2. I need to show that this is multiplying because it is geometric, and that's my formula. The next question says a bouncy ball drops from a height of 20 feet. The bouncy ball rebounds 90% of the height of the preceding bounce. What is the total? First off, total, you know that's sum. You see a percent, we know it's geometric. To the nearest, what is the total downward distance to the nearest foot the ball traveled up to the 10th bounce? So what I'm going to do is I'm going to use my geometric series formula because I know it's geometric and I know I'm doing a sum. And I'm going to do up to the 10th bounce, so S sub 10. Now the only thing here is that we know the height at no bounces because he's dropping it from 20 feet. A1 in this case is equal to 20 times 0.9 because it's going to keep 90% of the height from the previous bounce. So that means that 18 is really what's going to go in this formula because 20 times 0.9 is 18. So it'll be 18 minus 18 times 0.9 to the 10th all over 1 minus 0.9. When you plug that in, you end up getting 117 from your calculator. So let me just erase that. 117 is what you get. But you have to remember that the zero height was 20 feet. So even though you get 117 from the 10 bounces, you have to add the initial height because we're trying to figure out the total downward distance. So the answer is 137 feet. The next question says Jamie is selling apples. Her sales are depicted below. Looking at this graph, I know it's linear. Just a heads up, because it's going up by the same rate. It's actually going up by 5. That's the slope. So because I know that it's linear and it's going up by a constant number, part A tells me that this sequence is arithmetic. Okay, so you could say why? Because it's linear, because it goes up by a constant rate, a constant slope, a constant rise over run, something like that. It's adding something constantly, and it's always 5. Write a recursive definition to represent the cost of apples per bushel. Well, because it's arithmetic, I'm going to say my let statement. Let A1 equal, if you look at the graph, A1 is 5 apples. And I need to fill in my AN equals D plus AN minus 1. And that will be AN equals D is 5 plus AN minus 1. And that's your recursive. Now, Andrew is also selling apples, but the cost for his first bushel is 15. So his A1 is 15. He follows the same price pattern, which means that his D value is still 5. They want you to write an explicit formula in simplest form to represent Andrew's price per bushel. So what I'm going to do is I'm going to plug in to the explicit formula of an arithmetic sequence from the reference sheet. And A1 is 15 plus N minus 1. D is 5. Simplest form means you got to distribute and add like terms. So my final answer will be 15 minus 5, that's 10 plus 5n. This is his explicit formula. The last question says the table below shows the number of new stores in a coffee shop chain that opened during the years 1986 through 1994. Using x equals 1 to represent the year 1986 and y to represent the number of new stores, write an exponential regression for these data. Round the values to the nearest thousandth. So exponential regression. To get this, I need to put this into L1. X is always L1 and Y is L2. Now please never put years in your calculator. It will cause the calculator to go into an overflow. You have to always start with 1 or 0. Honestly, you want to start with what they tell you. They're telling you x equals 1 is 1986. So looking at the table, 1986 is here, 1, and 1987 is the following year, so that's 2. Nothing's skipping, so I can just keep counting up like I normally would. And you are going to plot 1 through 9, well, stat edit in your calculator 1 through 9 to list 1, and the 14 through 681 into list 2. And then once you enter that into your calculator, you're going to go to stat calc and do the exponential regression, which is choice 0. And you're going to fill into the y equals a b to the x. You want to round to the nearest thousands, which is 3 decimal places. So a is going to be 10.596 and b is 1.586, and just remember to do to the x. Also, please remember to make sure it's y equals. If there is no y equals, then it isn't an equation. Remember, they're asking for an equation, not an expression, so you need the equals. Now it says based on the table, so we're looking at the table for part B. What is the average rate of change in the price of gasoline from 1986 to 1994? Round to the nearest thousandth and use appropriate units for your answer. When you see average rate of change, they're just talking about slope. That's it. It's very simple. You're going to look at the table, because that's what they're asking for in this part, and we're going to figure out the change in y over the change in x. They tell you what y is. They say y is the stores and x is the year. They want from 1986 to 1994, so all we care about is this and this. So the y would be 681 minus 14. You can use the 9 and the 1 or the 1986 and 1994. I just used the years just to be safe that I didn't make a mistake counting. Okay, 1986, and when you plug that in, you should end up getting about 83.375, and labeling it, it's stores per year. The reason why it's labeled as stores per year is because stores was the y and years was the x, and when you read division or any type of fraction or any type of ratio, it's the numerator per the denominator, so stores per year. Now they say based upon your regression. That means we're looking at the equation. What is the average rate of change? We're still doing slope in the price of gasoline from 1986 to 1984. So we're still doing 1986 and 1994 for the bottom. So I'm going to do 1994 here, 1986 there. What you have to do, though, is get the values that go with this equation for 1986 and 1994. So what you have to do also is take your equation and find these values. So I'm going to find the value for 1994 first. To find that value, I have to type in 9 in the exponent, not the year, 9. And that gets you 672.776 minus. Now I'm going to type in the 1 for the 1986 year, and that tells me 16.805. So this gave me that, and this gave me that. And doing my math, my regression equation tells me 81.996 stores per year. Now, of course, this is not exact. Remember, your regression equation is only a prediction based upon the data. So these will never be exact. They should be close, which they are. They're only about 2 off, not even. So I think that the regression equation was a pretty decent fit. And that's really it. So good luck, study up, and look at your notes as well. And I'll see you soon. For this question, it says, while experimenting with her calculator, Angela creates the sequence 3, 10, 31, 94, 283. They want you to write a recursive formula for her sequence and then state the 7th term. So recursive means that you guys are going to have to state A1, which is 3, and then make a formula that has AN equals, and you need the previous term in there. I put a space in there because I need to figure out if there's multiplying or adding or both happening in the sequence. So what I'm going to do is start to mess around with the sequence and see if I can figure out the pattern. If it's adding, I'm going to add to the an minus 1. If it's multiplying, I'm going to multiply the an minus 1, which means the previous term. So now if I look at my terms here, I got 3, 10, 31, 94, and 283. This is A1, A2, A3, A4, A5. They also want you to find the 7th term. So I'm just going to do A6 and A7 because I want to find the rest of those. So now what I started to do is I started to subtract them to see the difference. I got 7 first. Then this difference was 21. Then this difference was 63. And then this difference is 189. And I started to notice that the amount it's going up by is multiplying by 3. So if I wanted to continue the pattern to find A6, I would multiply 189 by 3, and that would allow me to get the thing you need to add, which is 567. So 283 plus 567 is going to get me A6, which is 850. I'm going to do it one more time, times that by 3 to see what it's going up by, which is 1701. So then if I add 850 to 1701, I actually end up getting my 7th term, which is 2551. So this is one way to find the 7th term. But remember, we also need to figure out this formula here. We only know the first term, which actually gives me a point, but I need to figure out what's going on. Well, I know it's multiplying by 3 when I go up, so I'm going to mess around with that. Let's see. So if I do 3 times 3, that gets me 9. But what would get me to 10? Well, if I add 1, I'll get to 10. So I'll add 1 here. So let's see if this pattern continues. So let's say I took 10 and I multiplied that by 3 and I got 30. Well, if I add 1, I get the 31 term. And if I multiply 31 by 3, I'll get 93, and if I add 1 there, I get 94. So the pattern makes sense. It's continuing to get these terms here. So if I kept going and doing 3 times the previous term plus 1, I would create the pattern that's occurring. There's my recursive formula, there's my 7th term, and that's how you answer this question.